AC generator is a device which is used to convert mechanical energy into electrical energy for appropriate use. Now, based upon the power input, now generators can be of two types. One is AC generator and one is DC generator. So, slip rings are used in AC generator, whereas the direct current is used in DC generator. Hello students, welcome to my next online class. So this is the last topic of the chapter AC circuit. So watch the video till the end, and here we will discuss the working principle and how does a AC generator works, right? So AC generators are used in different places, like they are used in power plants, they are used in electrical scooters, they are used in sailboats, bicycles. Now the input which is being provided in that AC generator can be in form of steam, that it can in form of turbine, right? Now the principle on which the AC generator is based on is called electromagnetic induction, that is the Faraday's law of electromagnetic induction. So electromagnetic induction, what does this mean? Then if we change the motion of a magnet, now if I consider, let me give example of a small example. Let us consider this is a coil, right? And this coil is converted with one galvanometer, and I have taken one magnet here, right? North pole and south pole. When I insert this magnet within this coil spring, then what happens? Due to motion of the magnet to and fro, a magnetic field is changed. Due to change in magnetic field, what happens? A current starts flowing through this coil, right? So this was electromagnetic induction. So till I move the magnet, a current will be induced in the coil. Okay, if I stop moving the magnet, the current will also stop moving. So the current which is moving in the coil can be easily detected by the galvanometer. The same condition we see here in AC generator, because AC generator works on the principle of Faraday's law of electromagnetic induction. And what is AC generator? AC generator is an electrical device or machine that converts mechanical energy into electrical energy in the form of alternating EMF, right? So this was the definition for what we are using AC generator, and this was the principle. Now you see, when a conductor is moving inside a field magnet, when a conductor is moving in a field magnet, it changes its magnetic field, it cuts the magnetic field lines. Due to cutting of magnetic field lines, an EMF is induced in the same coil. For example, you see here, I have considered here two magnets, right? Field magnet. These are called field magnet or permanent magnet here. So within these permanent magnets, I have taken one armature. Now what is armature? Armature is a rectangular loop which is wounded by a copper wires. Now this armature rectangular frame is being placed between the north pole and south pole. Now when it is rotated, when this coil is rotated in the direction of arrow, that means I am rotating in clockwise. So when it is rotated, an EMF is induced in this coil, right? So the two ends of the rectangular coil is connected with the slip rings along with one brushes. So if I consider, this is brush 1 and brush 2, and this is ring 1 and this is ring 2. So brushes are connected with the slip rings, and further brushes are connected with one lamp to check whether an electricity or the current is produced or not, right? So you see, whenever a rectangular loop or rectangular frame armature is moved inside a magnet, it changes the magnetic field. Due to change in magnetic field, an EMF is induced in the rectangular frame, and which is being produced at the output, right? Now you see from the diagram here, if I consider this is the rectangular frame which is inside the magnet. Now if it is rotating once, now when it is like this, that is perpendicular, that means here maximum lines are cutting here, that means the point at A, when the side AB is perpendicular to the north pole and south pole, it has been seen that the angle is said to be as here 0, right? So angle is 0 means here it is said to be as 90 degree. So I have noted down here at different position what is the induced EMF. Now when the EMF induced in the coil is maximum and when it is minimum. You see at point A it is 0, 0. That means the graph is starting from 0. So at this point, this means that when the coil is at 0 degree, the coil moves parallel to the direction of magnetic field. When the coil and the magnetic field they are in 0 degree, so it is cutting the parallel lines of the magnetic field. Hence, no EMF is induced. So here it is starting from 0. But when it is moving to 90 degree, right? When the coil is moving to the 90 degree to the magnetic field, so it passes maximum magnetic lines of forces. So maximum magnetic lines of forces when it is gets passed, so the EMF is said to be induced. So high EMF is induced here in this position. You see in B, when the coil is at 90 degree, the coil moves at 90 degree to the magnetic field and hence induces maximum EMF. So in the graph also you can see the EMF is maximum. So similarly at point C, now when from 90 degree again it comes to 180 degree, that is opposite phase, the coil again moves parallel to the magnetic field and hence induces no EMF. So as long as the coil is parallel to the magnetic field, so no EMF is being induced. But when that position gets changed to 90 degree or 270 degree, so it induces maximum EMF, right? So this was the position. Let's see. So at A EMF was 0, at B EMF is maximum, again at point C. So when it is at point C, the angle is 180 degree rotation. Similarly at point D, again you see it is maximum, but it is opposite to that of EMF induced at B, that is in opposite direction, right? So when the coil is at 270 degree, the coil again moves at 90 degree to the magnetic field and hence induces maximum EMF. So when it is parallel to the magnetic field, it induces no EMF. Now when it is 90 degree, it cuts the maximum line of force, so it induces a high EMF. Again it becomes 180 degree. So as it becomes a 180 degree, again it becomes parallel to the magnetic field, no EMF. Again it gets turned and it forms 270 degree. But the EMF which is induced here, it is maximum but opposite to that of 90 degree. Right? Now again after rotation, again it turns and again it makes one rotation and comes to 360 degree. The coil has completed one rotation and again it moves parallel to the magnetic field. So again the EMF has been reduced. So this is how when a rectangular coil is placed between the magnetic field, due to change in magnetic field lines, an EMF is induced here, right? So this was the working of AC generator, right? I hope you have understood this one. So you can pause the video and write this in your copy, right? So for this class only this much. In my next class I will be starting a new chapter. See you soon.